today, we are going over this warm-up, but if you have a test, just write test, because you need to finish your test. No. Some people are still finishing. Third day, it is, yes, still finishing. Who has a test? I know one, and then no one over here. Okay, two, that's fine. Okay, so make sure y'all finish that. So don't worry about what we're doing until you're done with your test. Now, this is going to be relating to our notes today, and since we're not on our phones, right? So, what is happening each time? Okay, so it looks like it might be multiplying at first, but then notice 4 times 2 would be 8, and this is not 8 over here. So actually, we're just adding 2 triangles each time, right? So like these are the 2 new ones, and then these are the 2 new ones, and then these are the 2 new ones. So just adding 2 each time, right? So can you write that in a sentence that each time we're adding 2 what? 2 what? 2 triangles. Okay. And that's just basically you looking at a pattern and telling me what the pattern is. Very easy, okay? Write that down as a sentence on Tuesday, because Monday we were not here. So make sure you cross out Monday or put no warm-up on Monday, and then write that sentence. Now I'm going to pass out your tests so we can go over them. Our warm-up was a little bit of inductive reasoning, and that's what our little section is on today, part of our objective. So what is inductive reasoning? It is the process of observing data, recognizing patterns, and making generalizations on those patterns. Let's write those down. Let's write it down. All right, so this is one of the examples we said that you may have seen, but the sun has risen every day. Now, granted, this is relative. The sun doesn't actually rise. We rotate around the sun. You know that already. But it looks like the sun rises every day, and that's what we're talking about. So every day, same thing happens, right? Without headphones in your ears, please, please. So that's called the principle of induction. If you notice it happening every day, you assume it happens every day, right? Like every day I have to tell y'all, take out these headphones, please. Now, down here, by the principle of induction, if I see something happening every day and I make a generalization, that's called a conjecture. Have you heard that word before? Maybe in science, maybe in math. Okay? Conjecture, it's a statement about what you observe. Okay? All right. Now, this is kind of maybe some new terminology, finding the nth term. Nth. Now, that means n is some number, so the nth term is the term whatever n is, okay? So, this is what we're going to need. Oh. So write that down. Let's try it on example 1. First, I need to find A1. So let me show you where A1 is. A1 is right here. A1 is that number below the first term, which is what? 1. Okay? So A1 is 1. And then the difference, now I got to figure out on the bottom what's happening each time. So to get from 1 up to 5, adding 4. To get from 5 up to 9, also adding 4. So it's constant. So we're going to do the same thing. 9 plus 4. 13. 13 plus 4. 17. 17 plus 4. Thank you so much. Now, that goes over and over and over up to what we call n. N is any number, okay? The nth term is whatever. Now, we're going to use this over here to figure out the nth term. So we already know A1 is 1 right here, and we figured out the difference right here is 4. So let's just plug it in. A1 is 1 plus the letter D, difference is 4. And then you always put parentheses n minus 1 parentheses. What? So that's the nth term, that's the rule. And then we're going to use that rule to figure out the 20th term. I don't want you to keep adding 4 20 times if there's a different way to do it. Okay? So here's what we're going to do. We're going to rewrite this, but instead of n, we're going to write 20. Okay? So right here, 1 plus 4, parentheses, 20 minus 1. Do you see I replaced n with 20? And all I got to do is simplify that. Now here's the part that people mess up on. If you want to do that mentally or step by step on your own, you have to remember to use PEMDAS. So PEMDAS is called the order of operations. First thing you do is parentheses, then you do the exponents, then you multiply and divide together. then you add and subtract together. However, because here's what people do. They say 1 plus 4 is 5. Wrong. Already wrong. Okay? You don't add first. That's way down here. You do parentheses first. Now, instead of making this more complicated, did you know you could just type that in the calculator and get the answer, right? So let's do that. Right? So we're going to type that in the calculator. We're going to do a new document. Okay. All right. It was 1 plus 4, parentheses, 20 minus 1. If you can type it in, you'll get your answer faster. Okay, and it'll be right. So the 20th term gives us 77. Okay? So all I did was plug that in the calculator, and I got that. All right, now, down here, this is another way, another way to get the answers. Oh my gosh. You can write these down real quick on the middle part there, and then we'll do the bottom together. All right, let's do example 2. First thing I need to find is A1. So what's A1? I'll do this in a new color. Yeah, so A1 is 3. Now, to get from 3 down to 1, what's happening? Minus 2. Does everyone see why it's subtracting? Because we're going down, and then we're going down. So 1 to negative 1 is also minus 2. And then negative 1 minus 2, negative 3. Negative 3 minus 2, negative 5 minus 2, negative 7. So who could tell me what's my rule going to be here? So what's A1? 3. Now usually we put plus, but since we're subtracting 2, we're going to put, minus 2. Minus 2 and minus 1. So this one has an n. Well, but this is asking for n. Yes. So Obed, just so you know, this first number is always this first number, and then the second number is always the difference between these. And then you always put n minus 1 next to it. Okay. And then we're going to... What's funny? Then we're going to plug in 20 for n, right?